Good morning. Professor Kishore Chatterjee is having a PhD defense, so he has asked me to introduce my colleague. I'm very happy to introduce my colleague Anil Kottantharayil. Uh, Professor Anil Kottantharayil joined the department in 2006 after his PhD in electrical engineering from University Bhubaneswar, Munich, and 5 years of experience in industrial R&D in silicon semiconductor technology. His current research interests are in the areas of materials for solar cells and PV modules. He has authored and or co-authored more than 150 papers and conference presentations, and is an inventor or co-inventor of 17 national or international patents in the fields of semiconductors and photovoltaics. He is a distinguished lecturer of the IEEE Electron Devices Society and a fellow of Indian National Academy of Engineering. He was the head of the Center for Research in Nanotechnology and Sciences, that is CRNTS, and the Sophisticated Analytical Instrument Facility, that is SEF, at Bombay during 2018 to 2021. He is also a regular reviewer of more than 16 international journals. Yeah, he is a very active member and a co-principal investigator of the National Center for Photovoltaic Research and Education. Yeah, in addition, he is a regular cyclist and has gardening and beekeeping as active hobbies. He had won the Best Researcher Award, Paper Award in 2016. Congratulations to Anil Kottantharayil, and I'll invite him to make a presentation.
Thank you, Professor Fernandez, for this nice introduction. So I'd like to thank the committee for considering our work. So this is actually on some activity related to photovoltaic panels. So this paper was, you can see the title of the paper, Study of Soiling Losses on Photovoltaic Modules with artificially deposited dust from different parts of India. Okay, so this was published in 2015, and these are the authors. So Jim actually did his PhD with me, and then he is now leading the R&D in DEWA, Dubai Electricity and Water Authority. Sonali was a master's student. She is working at Intel, Bangalore. Professor Tamil Mani is from the ASU, Arizona State University. So he had been a collaborator for this work. This is me. So I don't have to put a photograph here. Okay, so I'll actually try to put this talk in the context of the photovoltaics, the national solar mission. So why this topic is important? So you know that we started this national mission in 2010, and the original target of installation of solar photovoltaics and thermal was 20 gigawatt by 2022, which was then later enhanced to 100 gigawatt by 2022. But then in the recent COP26, there was a commitment made to actually have 500 gigawatt of non-fossil fuel energy by 2030, and out of which 300 gigawatt will be solar. So that is a major jump. And what is the status now? So this is the status as on 30th of September from the Ministry of Power. So we have in the country total installed electricity generation capacity of 407 gigawatts. Out of that, renewables is 171 gigawatts, and out of this 171, 60 gigawatts is solar. So we may miss this 100 gigawatt target by a significant margin, but you can see compared to what was the original envisioned goal in 2010, this is actually quite a good achievement. And now there are of course many problems with the photovoltaics, otherwise the research that we do at NCPRE and so on and so forth would not be relevant. So one of the problem is soiling of photovoltaic modules. Okay, so this is the construction of the photovoltaic module. You can see the solar cell. Most of us usually talk about the solar cells, the materials in there and so on and so forth, but this has to be packaged. so that the whole module can survive in the field for 25 years. So, the warranty is for 25 years usually. So, you have polymers that are used for encapsulation, ethylene vinyl acetate containing polymer sheets that are transparent, and the front side you have glass, which is special type of glass for PV applications, and then there is actually 3 layers of polymers on the back side. Okay, one of them is Tedlar from the Corning, not Corning, I think DuPont. Okay. Now, what is the problem with the soiling? Soiling is basically as different kinds of things that can happen in the field. For example, these are mineral dust deposited on the glass. This can be bird droppings, especially if the solar panels are installed near some water bodies. You can have algae growing on it, all kind of stuff, pollutants, pollen. This is engine exhaust if there is some heavy industry going on, agriculture dust, or this is from NTPC, one of their power plants, thermal power plants. So, there's this trucks carrying the ash for dumping, and a lot of dust get deposited. So, they need to clean it every day, or even that is not sufficient. And then you can also see that if you try to clean it, this is due to dew, for example. It does not necessarily clean very nicely. So, you can have this kind of marks on the wafer, meaning on the glass. So, this then leads to problems. So, this is your glass, let us say this is your solar cell, EVA, and so on and so forth. So, this is what we usually think of solar PV, right, for all the scientific studies. The incoming solar radiation, part of this get reflected, and then it goes through the glass, maybe a little bit get absorbed in the glass, but at this interface something gets reflected. So, this is your glass EVA interface, and then you have some absorption in the solar cell, which is the most important thing. So, you need to make sure that as much as possible light is actually absorbed by the solar cell. But when you have dust, the situation changes. So, you can have reflection from the surface of the dust, which can be more than what you have from the glass surface, and then dust can also absorb light. Okay. And you can of course have a reflection from the dust glass interface, which could be more than what you have from the air glass interface. So, you have both reflection losses as well as absorption losses that can result in reduced energy production for the same irradiation. So, this is meaning it is not a very fancy research topic, but very important because you can see the economic impacts are huge. So, it is kind of slow and cumulative soiling that you can see that happens in non-desert locations. So, I will show you some data from IIT Bombay. Okay. Sandstorms are common in deserts, so that can be a major problems in very sunny areas, okay, in Rajasthan and Middle East and so on and so forth. So, the impact is soiling of the front glass, which reduce the light that can get into the solar cell. So, that leads to loss of energy, and then you can also have abrasion of the back sheet and the front glass. Typical problem in case of sandstorms. This can lead to safety failures and reliability issues for the whole module as well as for the power plant. Now, just how serious is the problem? So, this is an interesting slide that I compiled with data from Wikipedia and other sources. So, this was Mars probe that was launched in 2003. So, it is named Opportunity or MERB, and this was meaning close to 1 billion was actually spent on 2 pieces of this. But then 3 years into operation, this was actually moving around on Mars, and then dust storm basically covered the solar panels. Okay. So that stopped the power supply to all the electronics and other components on the they basically cut it off from the earth, and it was covered with dust. So many thought that, NASA thought that it was lost, but then later on the winds on Mars actually cleared off the dust, then it started responding again, okay. But then you know, it was supposed to have very short, I think 8 or 10 years of life, but then again, meaning electronics, everything was working fine. In 2018 again dust storms stopped responding, okay. But now there is no signal from this, so mission is declared as completed by NASA in February 2019. So it's a serious problem in space missions, especially when this kind of probes have to land on planets. Now back to Earth. Now this is our installation, test installation on our rooftop. So in the nanoelectronics building rooftop, there are two panels. You can see that there is one panel here, by the way, if you can't see it. Okay, the two panels. This is cleaned every day. Okay, and this panel is never cleaned unless you know, cleaned by rain. So you can see that the contrast is very huge, and you can figure out the energy loss. So we measure these two panels continuously, and you can find out the energy of the, you know, 1 minus energy of the soiled divided by energy of the cleaned panel gives you kind of energy loss, cumulative of course, and then you can take a rate of this energy loss by dividing the energy loss by the number of days. So if you look at this data, okay, so this is, you know, over 5 years that we have collected this data. If you don't clean the panels, it goes up to 40%, okay, loss, that the energy, the rating of the panel goes down by 40, in some cases up to, some of the years up to 60%. Yeah, so 100-watt panel or 1 gigawatt solar system, right? After soiling, you would have the rating would be only about 400, 500 megawatt. Okay, so this can be a huge loss in the energy, and hence the financial losses can be significant. Of course, the panels get cleaned during the rainy season, so you can see that the losses are small during the rainy season. Now, per day losses, if you look at 0.5%, 0.6% per day, and of course, it gets accumulated. So then we worked on, you know, predicting or assessing the loss for a complete year. Of course, that depends on the rain and other climatic conditions. So we actually came up with a methodology to assess this. We did an assessment for 11 years, and all of them are actually looking pretty similar. One thing that we have done here is that suppose you clean the panels once in 7 days, or once in 14 days, or once in 21 days, and so on and so forth, right? What would be the total energy loss? Now, why is this important? Because, you know, if I am setting up a power plant, right, maybe my profit margin is about 10%. Okay, so now out of that, you know, you can see this. We don't have anything here. So you have something here. This is your total revenue, and this is your cost, right? So this is your profit margin. Now, if you don't, the energy produced is what is giving you this revenue. That goes below this, then you are actually at loss. Okay, so 6% loss can be a complete washout of your profit in this business. So this is very serious problem, and we have then Jim actually produced this world soiling map, looking at the entire literature and put it on a Google map to say that, okay, you can click on this bubble. So then this window will pop up and will give you a location and gives you the soiling rate on this. So now Anil has repeated something similar. They keep on updating this. We did the last update, I think, in 2019. Now, economic assessment, this is a very recent paper, 2019. So they actually went ahead and actually calculated what is the revenue loss due to soiling. So 3.5 to 6 billion US dollars per year in 2018 globally, and India estimates $300 million in 2018 alone. But then if you use these numbers to project what would happen in 2030, so $3.3 billion per year will be lost just because of soiling. Now, what is the meaning? Can we, just to put it in context, so the PLI, this is the production linked incentive scheme that the government has announced recently, or meaning in fact some of the companies have already received money under this. This was $2.4 billion was given for PV manufacturing incentives. Okay. So they're a difficult problem because the dust is different at different places. So these are from various locations in the country, a mineralogy study, you can see the color also is different. And then for the same amount of dust on the solar panel, the energy losses can be significantly different depending on the clay content and the mineralogy of the soil, because the absorption of light would be different, and also it impacts different technologies. So amorphous silicon solar cell technology, or cadmium telluride, crystalline silicon, and so on and so forth, also differently. Then the dust at the same place can also change with seasons, for example, and this is from Pondicherry, some dust we collected from the solar panels, ground and roof, that's different. Mumbai dust itself is different in 2 years, 2013 and 16. This makes these problems quite difficult, challenging. You can see here soil can be alive. This was a collaborative activity with NREL. You can see this is basically fungus growth on the solar panel, on the soil. Okay, so you can basically kill the solar panel energy production. Dubai, you don't see as much of this problem. So by the way, by this time, Jim was already in Dubai and he was participating in the same project. So it's a fairly difficult problem, practical issue, and the mitigation means that you need to clean the panels periodically, so that is expensive, and anti-soiling coating, so you can apply coatings which actually reduce the soiling. You can do module mounting configuration, some work that we have done on this. Robotic cleaning is one of the solutions. So now the issue is that if let's say you have a coating, nobody has actually come out with a commercially viable, reliable coating. So we have developed methods to test, if you have a coating, for example, how to test its reliability. Okay, so many companies are coming to use this. I think 2 more slides. So in summary, soiling of PV glass is an important problem due to high energy loss that it can result in, and it can actually result in non-viability of power plants if it's not controlled. It's a difficult problem for all the issues that I mentioned, and cementation of soiling on the glass is a problem. So basically, at some point, it is not possible to clean the soil from the glass. Okay. This is one issue that we are actually now working with many companies and partners to develop solutions to mitigate this problem. Okay. So I'd like to acknowledge Professor Vasi and Dari Kasmersky, because they introduced us to this topic and said that we should work on this. Okay. Many students and collaborators from various institutions.
Thank you, Anil.